Hello everyone, welcome to Java Tutorials. My name is Kishore. In this video, we will discuss about another interface of collection, that is set. Set is used to maintain unique elements. There are three implementations in set, which are hashSet, which doesn't maintain the order, then linked hashSet, which is going to maintain the insertion order, and the TreeSet, which maintains the sorted order. Let's first see how simple types are stored in these classes. Later we'll see what happens when you add the complex types, and also you will observe an interesting behavior of these classes while working with the complex types. So first thing first, let's create a set reference and maintain string elements in three different implementations. Let me create first the hash set object. Let me add some elements, probably the fruit names like apple, then grapes, orange, banana. So these are the elements I have added. Let me use a for loop to print the elements present in the set and see what happens. If I print the value of s and if I run the program, I would see all the elements. Let us try to add a duplicate element orange and we'll see what is the output. See, there are only unique elements added in the set, and notice it is not maintaining any order. So you have inserted apple, grapes, orange, banana, but the order is not maintained. Let us change this hash set to linked hash set. So linked hash set, if I run the program, notice it is maintaining the insertion order. As linked hash set also doesn't maintain duplicate, it is not actually adding the duplicate element orange. Next, the tree set. So if I use the tree set and if I run the program, look at the way the elements are maintained. It is maintaining the sorted order. So this way, the set implementations are going to work. But what happens if you try to add complex elements? Let's see. Suppose I have one employee class. Let me create an employee class with three properties: ID, name, and salary. ID, name, and salary. Let me generate two constructors, and we will also generate two string and setters and getters. So we have an employee class with three properties: ID, name, and salary, and a parameterized constructor to initialize the properties, two string method to return the object information, then getters and setters. Let's try to add the complex type in the set. Firstly, I will use hash set. So test set complex type. I will choose the main method. So I will create set employee type employees, then hash set. Now what we will do, we will try to create employee objects and add it into the set. So I will try to create employee object by passing ID, name, and salary. So let me pass some number, Raj, and salary. Then 4, 5, 6, 7, 8, 9. Then 2, 2, 3, 4. We will give some names to these employee objects. We will also change the salary. So if I use for loop, I would write employee colon employees, and then I will print the E. Let us run the program. We are seeing employee objects added in this order. It is not maintaining any order, but let us try to keep one duplicate employee object, maybe Arun. If I copy paste the same employee object, if I add, what happens? Observe the output. It is not determining the duplicates. You can see this employee object, which has an ID 789, is still present. So, what could be the reason for this? The reason is the hash set is unable to determine the duplicates for complex types because it maintains the elements in a container called hash bucket, which is called as hash map, that is backed by hash table. So where these employee objects should be stored is purely determined by the hash code of every object. So what happens is every time you call the add method to add the object, let's say employee one object which has the ID 123, and next is you're adding employee two object, then you're adding employee three object, employee four, and employee five. So totally you are adding five employee objects. Whenever you add any object, the add method is going to invoke the hash code of that object. Now you might be thinking, where is the hash code of this employee object present? The thing is, employee class has an hash code that is derived from object class. Though there is no hash code method present in employee class, nowhere we have implemented hash code. What happens is it is going to call the hash code method of object class. Let me open object class and show you the method hash code. And there is one more method which is internally called while adding, that is equals method. But when equals is called and when hash code is called, we will try to understand in this example. When hash code is called, usually what happens, it is going to get one integer value, which is a numeric value that is derived from the object's memory address. Well, it is not the real address, it is completely abstract, but you will get some numeric value. Let's say the numeric value is 6789, something like this. And this value is going to be sent to the hash map to determine the bucket, means to determine to which bucket this employee object should be stored. And that inbuilt function is actually an hash function present in the hash map. And this 6789 is going to be supplied to the hash function and it is going to get the bucket number. Let's say the hash map has some buckets, like three buckets: bucket 1, bucket 2, and bucket 3. And each bucket we will give some number like 1001 to 2000, 2001 to 3000, and then 3001 to 4000. These are the numbers which we are just assuming, but the hash function, whatever the bucket number it is going to generate, is completely abstract again. And the hash function knows what is the correct bucket number that needs to be generated for the object to store in the hash map. But to understand the working of the hash set, we are trying to just assume some dummy numbers. Let's say the hash 6789 generates one bucket number that would be somewhere between 1 to 50. Then what happens is, based on this number, the hash map is going to add the element in the bucket number 1. It means this goes to the bucket number 1. So remember, though you are using hash set, it internally uses hash table or hash map, to store the element. Next, when the second object is added, what happens is again on that employee object hashCode will be called, and let's say the hashCode of the employee object is some number which is like 8908 something like this, and it is again supplied to the hash function, and this is going to generate some number which will be always within the range of 1001 to 4000. And once again I'm telling they are just our assumptions. Okay, so let's say it is going to generate some number like 1980. Now what happens? It goes to the bucket 1 only. But now what happens? In the bucket 1 already employee 1 object is added. When employee 2 objects is added, bucket 1 already has the employee 1. So there is going to be an object collision. In that case what happens? Whenever there is an object collision, the hash map is going to invoke the equals method on those collided object. It means before adding to the bucket, what it does is it is going to call the equals method on that object by passing already existing object. And what equals method would do, or where is it present? Again, it is present in the object class. It is not present in employee class. So what is object class? Employee object class equals method is doing is it is just comparing the memory address of the objects. When these two objects memory address is same, then they are identified as duplicate. If these two objects memory address are different, then it is going to be treated as they are not same. It means they are unique. The equals method just returns true if both the objects memory address is same, else it returns false. That is the object class equals method implementation, because it is comparing two objects reference. Because in employee class it is not overridden, the equals method on object class will be called, but what happens now is employee 1 and employee 2 both the objects address is different and they are not treated as duplicate, they go to the same bucket. So you need to understand here, if there is an object collision, then equals method will be called. Next again, employee 3 hash code will be called and some number, let's say some number is generated and hash of some number, and it probably goes to 2002, and no equals method will be called because the bucket number is now 2. And let us use another employee object. How it is going to work is again hash code will be called. Let's say this is going to generate some number, and that hash number will be used to determine the bucket number. Let's say it is going to generate 2002. Can it generate same number? Yes, of course it can generate the same number, because there are only three buckets if we assume. Sometimes the objects might go to the same bucket number, and also the range can also be the same value. Means if employee 3 gets 2002, employee 4 also can get 2002, because we have only limited number of buckets. And this time bucket 2 already has employee 3. Bucket 1 has what all the objects? Employee 1 and employee 2. Now what happens? Employee 3 is present. Employee 4 will collide with employee 3. So before adding the employee 4 to bucket number 2, it is going to call the equals method on employee 4 and passes the employee 3, and object class equals will be invoked, and it is going to understand that their address is not same. So it is going to consider that is also unique, and bucket 2 will have employee 3 and employee 4. Let's say the last employee object generates some hash code, and it is going to have some hash code like this, and the hash of this number, assuming that it might generate some number like, now we will take 199. So 789 and 789 we are adding. So now what happens is it is going to again, it is going to actually collide with the object, because it goes to the bucket number 1. Now when it goes to the bucket number 1, what happens? In the bucket number 1, employee 1 and employee 2 are there, and obviously this time also there won't be any problem. So employee 1, employee 2, employee 5, all their addresses are different, And in the bucket number 1, employee 1, employee 2, employee 3, employee 5 will be added without any problem. Because all the elements are generating the hash code, and though they go to the same bucket in 2002, you can observe in employee 3 and employee 4, I purposely gave the same bucket number. Though they go to the same bucket number, the equals method is not actually telling they are equal. They are telling they are different. If the equals method had determined both the objects are equal, then hash map will not add the object. That is, the new object which you are adding is considered as duplicate and it won't be added. Because the equals method is not implemented in employee class, but it is invoking the object class equals method, they are not considered equal. But if the employee 4 object had gone to a different bucket, let's say it had generated an hash code of 5674, but the hash function of 5674 generated 3002, then there won't be any collision, and bucket 3 is going to have the element called EMP4. So bucket 1 has these three elements, bucket 2 has one element, bucket 3 has one element. What we have to understand is when two objects are equal, like this 789 around 75,000, which are equal, we want to ensure that they should go to the same bucket. Let them collide and let the equals method determine they are equal. But there could also be a chance that, like in case of employee 1 and employee 2, though they are not equal, they can go to the same bucket. It can happen because we will be having only limited number of buckets and the range. For that reason, we have to override the equals and hash code. We cannot use the object class equals and hash code. So we need to override the hash code and equals in the employee class, and we need to tell if the objects are same, the hash code also should be same. So what we should do is we should create hash code and equals, but in Eclipse there is a shortcut to generate equals and hash code. We don't have to type. We will just generate it. Let me generate after the toString. Anyway, you can generate in any place, not a problem. Let us right click and go to source and generate hash code and equals. Observe, Eclipse is forcing you to generate both because it is mandatory to generate both, as hashset is going to call the hash code and equals automatically while you are adding the elements. That is obviously in the hash bucket while it is added. So you can select on which field you want to generate hash code and equals. Let me choose just ID so that the hash code will be generated based on the ID. This is one inbuilt class called objects, which returns an hash method, which returns an hash code of the ID property. And equals method is just going to compare two objects ID. Now, what we have to observe here is the hash code is not now based on the object class hash code. It is based on the ID of your employee object, and equals method is comparing the ID. Now what would happen is when employee 1 is added, it is going to generate the hash code, correct? When the hash code is invoked, the hash code having based on the ID means if the employee 1 and employee 2 have the same ID, obviously their hash code also will be same. So for employee 1, let us say the hash code is, let us keep ID itself as the hash code, and we will keep employee 2 hash code is 456, employee 3 hash code as 789, employee 4 hash code is 789, and this one is 234. Now we have to change all these things, 456, then 789 and 789, lastly 234. So this hash function is not same as the objects.hash. It is different. We got an hash code. So what happens is when the add method is called, hash code will be invoked internally by the hash map, and that hash code will be passed to the hash function, and then it is going to get some number. Now 1, 2, 3, let it generate 1, 2, 5, 0 and goes to the bucket 1. Let 4, 5, 6 go to the bucket 1 itself. In that case, what happens? Bucket 1 is going to already have one employee object, and hash collision happens. So employee 2 is going to be compared with employee 1. And what is equals method doing? It is comparing the memory address. That is, it is checking, are ID of EMP2 equal to ID of EMP1? No, they are different. Employee 1 ID is 1, 2, 3, employee 2 ID is 4, 5, 6. They are different. Then it will be added because equals method returns false. Then 7, 8, 9. So let's 7, 8, 9 get this bucket number, that is 2002, and let it go to bucket number 2 itself. Then what happens to the 7, 8, 9? Once again, if you add the employee object which has the ID same, then the hash code will be 7, 8, 9 itself. And the hash of 789, if it had given 2002, this time also it gives 2002. That is how the hash method of your hash map works. Now what happens? It has to go to bucket number 2 itself. It will not go to bucket number 3. And then the bucket number 2 has employee 3. So what happens is the new element employee 4 is going to be compared with employee 3 by invoking the equals method. Now, what is equals method doing? It is overridden to compare the ID of one object with another object. Employee 4 ID is 789, employee 3 ID is 789. They are equal. So it is going to treat their duplicate. It means the new element which you are adding won't be added. So this time the bucket number 2 will have only employee 3, employee 4 will be ignored. Then the next element employee 5, when you add, let's say it gets the bucket number 1, which has 1999 as the bucket number, and the bucket 1 is going to have now what all the elements it has is employee 1 and employee 2, and this time it is going to invoke the equals method on all the elements. Now employee 5 is going to invoke the equals method by passing the first element employee 1, and the ID of EMP5 and ID of EMP1, which are not equal, because 1, 2, 3 is the ID of EMP1, 2, 3, 4 is the ID of EMP5, they are not equal. Then it has to again compare the next element which is there in the bucket 1 is 2. So employee 5 ID and employee 2 are again not equal. So this time bucket number 1 will have employee 1, employee 2, employee 3, because all are unique. This way it is going to have only one. This way it is going to actually avoid the duplicate elements. By invoking the hash code, it determines the bucket number, and by whenever there is a collision, it is going to invoke the equals method. For that reason, we should override equals and hash code. Now let's run the program and see what is the output. So let me click on OK. If you observe the output, 789 is added only once. It is able to identify the duplicates because of the equals and hash code. So that's why you should override equals and hash code. Then you can also observe that the order is not maintained. Similarly, even linked hash set also uses the hash algorithm. But before that, let me create one statement in hash code. What is the proof that hash code is called? I will just print hash code statement with a value of ID in the employee class, or we will print objects.hash itself just to understand what is the number it is printing. And we will also print the system.out.print statement. We will write in the equals method by writing equals method with an ID, so that we can understand internally while adding the element, equals and hash codes are getting executed. Let's now run the program and see what happens. Look at the hash code print statements are appearing. Hash code 154, 487, 820. That is probably when you added 789. See, two times we are getting 820. That is what the hash code we are getting from objects that hash method, and look at the equals method is called only once because there is a collision when probably next time when you add the element which has the ID 789 and Arun, this one, it is actually invoking the equals method and it is identifying both are same. So that is the proof that hash code and equals are getting executed. But there is one more implementation which is an extension to the hash set, that is linked hash set. We will use linked hash set also. If I use the linked hash set object, even this also uses hashing technique to maintain the element, but this is going to maintain the insertion order. So if I run the program, I should see the elements in the insertion order 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2, 3, 4. And this is the proof that hash code is getting called even when you add the elements in linked hash set. However, when you use the tree set, what is the working of tree set? Tree set is going to maintain the element in sorted order, but it cannot sort the complex types, it will give error. So if you use tree set, you will not actually get the output, you will get an error that is called as class cast exception. The reason is TreeSet is going to maintain the element in sorted order. We need to either implement comparable interface in employee class, or in the TreeSet we can pass the comparator implementation. But in TreeSet, hash code and equals won't be called. So now why hash code and equals are not called? You might get a question. The reason is the way TreeSet maintains the element is in sorted order based on comparison of the elements, or based on the ordering, it is going to determine the duplicate. That is why in TreeSet, the hash code and equals will not be called. So what we will do, we will pass a comparator implementation to the TreeSet. So it has to determine the order based on what? ID or name or salary you can mention. Let me write here, it has to determine the order based on the ID. Let's say get ID and e2 dot get ID. Now the tree set is taking comparator implementation and it is telling that compare the two objects ID and then sort. Now we are going to get what output, let's see. Observe, we are getting the elements sorted based on the ID, that is 1, 2, 3, then 2, 3, 4, then 4, 5, 6, and 7, 8, 9. Please observe, hash code and equals are not printing. It means tree set is not actually invoking hash code or equals to identify the duplicate. The duplicates are identified based on the order. In case I write here 789. Look at the 789, it is not added. One more time. But it without invoking equals and hash code, it is determining based on the ID because we are comparing based on ID, it has to sort. But if I write based on maybe salary, like even that salary, if I want to sort based on salary, I would write double dot compare, then even dot get salary, then e2 dot get salary. This time, observe everybody's data will be displayed, but 75,000 is repeating. Let me change this to 78,000 and let me run this program. Now see, it is still printing 789, but the salary is 78,000. Another 789, the salary is 75,000. So TreeSet is not going to invoke equals and hash code. It is going to determine the uniqueness based on the ordering. If the particular property is repeating, then it is treated as duplicate. If I make this one 75,000, what happens? Let's see. So Raj 123 ID 75,000 salary, but Arun also has the same salary 75,000, but ID is different. Raj ID is different, but they are considered as duplicate this time. See, only Raj value is coming, but Arun with 75,000 is not coming, but Arun with 78,000 is coming. Correct? So that is it about the hash set, linked hash set, and tree set implementation, how it works. See you in the next video. Thank you so much.